So now, without doing any further delay, let's move on to the next presentation. This is coming from Claudio Martins Godinho. He is going to talk on evolution of AIKO's ABC technology. Claudio, the floor is yours.
Good morning or good day, everybody, depending where you are. Can you hear me well?
Yeah.
Okay, I will share my screen here. I think you can already see my screen.
Yes.
First, to thank you, Shravan, for the presentation, introduction, and for the TaiyangNews for the invitation for this event here today. As you said, I have a little bit presentation here that I'm going to talk a little bit about AIKO and the evolution of the AIKO products with the ABC technology. So starting presentation, talking a little bit about AIKO. For people who don't know the company, AIKO have been on the market, on the solar business, PV industry for around 16 years. Okay, we have bring to the market some disruptive technologies. We have grown a lot worldwide, as globally AIKO have more than 10,000 employees. And if we look at the cumulative shipments between cells and models, we have already shipped more than 160 gigawatts. So it's quite interesting from AIKO is that we have 20% of our employees dedicated to the R&D, okay? Because AIKO is dedicated to always bring the most innovating and advancing products and technologies, even for the product side and for the manufacturing engineering side too. So what we want to do as a company is trying to make most energy as possible with all sun ray, let's say, trying to get the maximum energy from each square meter of solar models. Okay, so for this, AIKO have already developing a few factories on China. On this moment, we have 6 factories working. 3 of these factories are already dedicated to production and manufacturing of cells and models with the back contact technology, with our ABC technology. So we can say that on this moment, we have already 35 gigawatt production dedicated to the ABC technology, to the all back contact cells that we as AIKO manufacture. As AIKO have been present on the market since 2009, we have bring a lot of different innovations to the market. Okay, so we have been really present with the PERC technology, where we develop a tubular PERC technology where we reduce a lot the cost of manufacturing the PERC cells. Okay, we invented the mass production for the G12 cells of 210 millimeter and for 166 technologies that been really mass product on these, but now we are on the N-type era. And on the N-type era, AIKO decided to really dedicate strongly to the back contact cells. With our R&D centers, that we have 3 R&D centers worldwide, we have really invested on this, and we are really pushing the limits on the back contact technology. So in 2021, we officially released our ABC cell. Okay, then on that time, our cells are reaching 26+% efficiency. Okay, we have been evolving our technology during these years, and on this moment, we are already starting to reaching in the 25% efficiency on the models. So we are really making a huge improvement on the efficiency and pushing the limits. If we think that the technical limit of PV conversion efficiency for the monocrystalline silicon cells, it's 59.56%. We decide that back contact, we have a vision, let's say, as a company, that the back contact is the future technology, and we think that the back contact will be the mainstream technology really soon. So we have been pushing really R&Ds, and we think not only us think like that, more players on the market think like us, and because with the back contact technology, with the crystalline cells that we have today, it's the way that we can have the most efficient cells, let's say the most power per square meter, so we can produce more energy. Okay? To produce our back contact technology, we need really good silicon wafers with extremely high resistivity silicon wafers. Okay, but with these cells, we can have a much bigger light sensitive receiving area. So the cell front face, it's free to receive the radiation and to produce more energy. Okay, we have a passivated contact. Back contact cells positive and negative passivated contact structure. So with this, we can optimize the moving of the electrons, and all the metal coating and contact combination that we use on a metal can help us to reach a really, really high efficiency on our cells. We have been, let's say, leading in some way the development of the back contact and pushing for the back contact to be the mainstream product really soon. We think in the 3 years, back contact technology will be the mainstream on the market that we have. The reason why we see this is because if we want to continue to get more power per square meter on the back contact technology, we have more way to improve. The theoretical limit that we have for the crystalline cells, as I said before, is 29.56%. On this moment, we are already reaching on our production cells more than 27.2% efficiency on the cells, and reaching on the production cells more than 24.6%, okay, on the production of the models. So we are seeing really a huge improvement as we start to push with our first production lines for tests in 2019, and starting with a really gigawatt scale production in 2021. Okay, and right now we have already the 3 factories pushing these limits to the thing. So with this, what we see is that from the TaiyangNews top models, we have been on the top for consecutively for the last 28 months. So AIKO is really pushing on this part. But not only for the efficiency side, our models are showing their values. We are bringing more benefits. Our models can produce higher yields. If we talk about the full blacks, it's extremely aesthetic, perfect model. A full black, really good integration on the rooftops. One of our key features that we bring, it's really changed the way that people look for solar, is the partial shading optimization. We bring a huge benefit in the situations of partial shading optimization. Due to our back contact technology that we use copper for the metallization of the cells, so with this, the copper is mechanically stronger, so we bring a huge increase on the mechanical resistance to the microcracks of the cells. And of course, all the benefits that are in some way similar to the N-type cells, that we have a really low degradation in the first year and the years after. Okay? Because our cells are more efficient, and the way we do the processing of our cells, our temperature coefficient is much lower, really low, and quite good for performance for really hot weathers, and even associated to the partial shading optimization, you have a much lower hotspot temperature. So one of our key features that I really like to emphasize is our partial shading optimization. These have all driving us to grow as much as we are doing until today, because customers are really seeing that is a huge benefit for the PV systems. Okay, in a traditional model, when a cell is shaded, the resistance of this cell increases a lot, and the current to pass through this cell will have a huge voltage drop, making the bypass diode to get activated. So what we're seeing is on the AIKO ABC cells, we can do a huge improvement on this part. So we can really handle the shading situations, because the current, in case of shaded cells, the current can still flow through the cell, okay? And with this, the energy can still flow out of the model. So we can see it here, as I say, a comparative part here on a shaded situation, on this case caused by a rod that's crossing the shadow across the model, okay? Our model is affected, okay? But what we have done is that we can still produce much more energy, because not all the bypass diodes are getting activated in the shading situations. So with this, we see in different situations, the way that the AIKO model is dealing with the shading, even in the case of dust in the down part of the model, that the bypass tiles are not getting activated and the energy produced by the other cells can still flow out of the model. Correlated to this, we have a quite good high temperature restriction. Okay, the hotspot, it's an important point. And then in case of situations where the cells are shaded, okay, the resistance of the cell will increase a lot. And in traditional cells where you have a positive on the top and negative on the back, the current need to flow and crossing all the thickness of the cell. With this, the hotspot temperature will increase a lot. In the case of AIKO ABC technology, in the case of shaded situations, the resistance of the cell will still get really high, but the current can flow from positive to negative with a minimal voltage drop. So let's say the temperature of the hotspot will not be so high. So this can bring a really huge benefit on the reliability of the models in the case of shaded situations. But we say that we are a new era of ABC technology because we continue to make evolution of the ABC technology. Okay? The market has been evolution. Before we had PERC, now the mainstream is TopCon. For this, we see evolution on the power and the efficiency of these models. With the ABC technology, we can still improve this efficiency, but now we are coming with our third generation, we call the ABC Infinite, that we see that we can bring a really increase on the efficiency, on the power of the models on the same size, really high compared to the typical technologies that we have on the market today. How we can do this? Because we are increasing the density of cells on the model. So we are moving and hiding the bus rebar to the back of the cell. So with these, we can increase the area of the model covered by cells in 1.4%. Okay? It's a challenging for the traditional technologies because to do that, they need to float the rubber bar, and with this, we can generate some issue with the microcracks on the border, and they still need to have an extra area for this floating of the ribbon. And other thing that we are doing is the overlapping of the ABC cells. And with this, we can have an extra 0.4 of the area of the front side of the model with cells covered by cells. So increasing, let's say, the model efficiency in a global. We can do this because we have the positive and the negative on the back side of the model. So what we have to do is a soldering on the same level. Okay, so all soldering on the same level. So with this, we keep them really good mechanical resistance of the models. We are present on the residential market. We are growing quite a lot with our most famous models, NeoStar series, in this case, the Infinite, with the full blacks, single glass and dual glass. We have it available too with a black frame with a white back sheet. So with this, we are really reaching really high efficiency in some of the models already, production models and selling models surpassing the 24% efficiency, okay? Keeping all the good benefits of the temperature coefficient and the low degradation of these models. For the C&I market, we have quite interesting products too. We are with the 72 cells that on this moment, we are delivering around 650 watt on the 2382 by 1134 size. And for the CNMI market, we have a quite interesting model too, a lightweight model. That is a model with under 2 square meters that weighs 8.6 kilos. And for the case of the bigger projects, we are aiming quite strong on this part with our products. We have two versions. We call it Polaris for the ground mounting systems and the series for the floating systems, especially floating systems near the seaside, where we can offer a better encapsulation, a better frame, corrosion protection, and still some waterproof caps to protect the connectors. Okay. We can really bring high efficiency on these models, high power density per square meter. So with these, we can help customers to generate more energy, okay, and to lower their BOS costs in general. A little bit my presentation here today about the AIKO product. I don't know if you have any question that you want to make to me, feel free.
Great, Claudio. Thanks a lot. I think a very interesting presentation. So you showed a lot of animation that really explains a lot. So I have a lot of questions. Maybe I will reserve them for the panel. But one question is, why are you overlapping? Because unlike the traditional both side contacted module or cell technologies, where you have to, bend from one side to the other side, you don't need it. So why do you have to overlap?
With this, because it's the way that we found to make the best way cost effective on the production lines to do this and to increase the density of cells on the model. Okay, because on our models, especially if they have a white back sheet, what you will see on our models generation 3, you will see rows of cells somewhere.
And one more quick question. So how far are you silver free? Is it completely all you enter your production, or is it in stages?
All the metallization of our cells is silver free. Okay, because all the plating on the backside of the cells we use copper. Okay, because we have our back contact technology. We use copper. Copper have the benefits in some way to be silver free. It's some way more friendly, more ambient friendly. It's cheaper too, and it increase a lot the mechanical resistance of our cells. Okay, even during these shows, we have shown an impact machine that will fall down 2 kilos over the cell, the proper cell, and we can see really how the cell is dealing with these impacts, because mechanically the copper makes the cell much stronger.
Okay. I think there are also a lot of questions already in the chat window. Would be great, you or someone from your team can answer these questions in the chat window itself.
Okay.